Alrighty, so last time we made this colorful quad of 4 vertices using indexed rendering, and today let's add a texture to it. So I have downloaded some images from itch.io, just some free assets, and let's just take maybe this one and use that as a texture for our quad. And let's think, what do we need to do to make that happen? So we need to load the pixels, we need to create texture on the GPU, we need to upload pixels to the texture, to the GPU texture, then we need to assign texture coordinates to vertices. We need to create a sampler for the shader, and we need to make shader sample colors from texture. So let's just start with loading. So we have this file. We could maybe embed it like we do with shaders, but in my opinion that doesn't make much sense, because we would need to load the PNG, uncompress it, and work with just raw pixels. So yeah, let's maybe just not embed it and load the file. And for loading the file, there are multiple options. There is the SDL image library here, right? That is part of the SDL project, but there is currently no Odin bindings for the SDL3 version. So yeah, maybe let's not use that. Then there is a core image package in Odin itself. It should work, but I never really used that, because there is a very popular STB image library for which we have official Odin bindings in the vendor collection. So let's maybe just use that. We can say stbi vendor stb/image. Here it is, right? And if we open it, we will see that currently the Odin language server has some problems parsing it, but nevertheless we can use it. And there are some functions for loading from files or also from memory if you still want to embed the PNG. Let's use this one. This will return us a pointer to bytes containing pixels, 8 bits per channel, so 1 byte per channel, and we can specify how many channels do we want, and even if the image has less channels than that, it will automatically convert that, so that's nice. And it will also fill these pointers that we pass to it with the values of width and height and the number of channel in the original file. So this is something that we are gonna use later. So yeah, let's just load the pixels. Let's just say pixels equals stbi.load. We specify the file name, so this would be our Cobblestone _1. In my case, you can use whatever you want, of course. And here we need to point it to some memory. So let's create a variable, image size, something like this, right? Just a pair of two i32s, and we can just point to it, image size x, image size y. And for channels and file, we can actually pass nil because we don't care, and it will not crash, it will just not fill the data here. But we want to pass desired channels as 4 because we want to simply use RGBA pixel format. And yes, that will give us a pointer to pixels, as I said. And we can maybe assert that they are not nil. So this is basically done. Now we want to create a texture on the GPU, and for that we just do texture equals SDL create GPU texture. We pass the device and the create information like most of the other create functions in SDL library. So let's take a look at what we need to specify here. So the type is the texture type. There are multiple texture types like array images or 3-dimensional images or cube maps, but also the most simple one, just a single image, is this T2, basically 2-dimensional image. We can even omit specifying this because this would be the default one. the format is something that we cannot omit, and this is important. This tells how to interpret the data of the texture, and there are a lot of them. They have to do with different texture format, compressed textures, and different color spaces and whatnot. We're gonna use this one because we do have 4 channels and each channel has 8 bits, so this works for us. And the unorm basically means that in the shader, when we sample the color, each channel will be a normalized float, so from 0 to 1. So this is what we're gonna use for the format, just like this. Now, if we will go back to create information structure, we need to specify the usage here, right? The usages can be different. If it's a render target, we would need to specify its color or depth target. If it's compute storage, we would need to specify that one. But if we would just want to sample from it, we would specify usage and just a single bit of sampler. Then we need to specify width and height, and this is what STBI image gave us. So we say width equals image size X and height equals image size Y. This of course needs to be converted to U32 because STBI returns I32. Then this layer count or depth, this has to do with different texture formats, like for 3-dimensional images or arrays, we would need to specify how many layers do we have, but since we are using just a single 2-dimensional image, for us this would be 1. And then this num levels is basically also 1 because this is a number of MIP levels. So for MIP mapping, we are not using that, so we have just 1 level. And the sample count has to do with the render target, so it only applies there, so we don't care about that. Let's see if it is created. Yes, it is. So we can consider that done. And now we need to upload the pixel to the GPU texture. Uploading the pixels to the GPU texture is done via the transfer buffers, just like with the vertex and index data. However, there are some considerations regarding the alignment that we need to take care of. For example, the upload to GPU texture function that we're gonna use mentions that the data must be aligned to the texel size of the texture format. So the texel size is how many bytes one texel in the texture takes, so basically just like a pixel, right? And with our texture format, that would be 4 bytes, so 4 channels, 8-bit each channel. So the data has to be aligned by 4, so all the offsets. That's one consideration. And another one has to do with direct 3D12. If you use that, the data, the offsets must be aligned basically by this number 256, or even better by 512. And we could align our data in our transfer buffer that we use here. That's possible. We would just need to recalculate the size to accommodate proper alignment. But what we could also do is just create a separate transfer buffer and just put our texture at the very beginning, so we don't have to care about the alignment. So this is what I'm gonna do for this simple example. Let's just create another transfer buffer. That would be maybe a texture transfer buffer or something. And we need to specify a byte size of the pixels that we're gonna upload, right? So pixel byte size, or rather pixels byte size. And let's see how to calculate this. So we have the pixels and we have the image size, right? So we need to basically multiply the number of pixels, which is image size X multiplied by image size Y, multiplied by the texel size, so the number of bytes per pixel. So for this format, it's this, so we have 4 bytes per each pixel. So this is our byte size, and we are using it here. So we create a new transfer buffer just for the texture. Now we can just copy the memory. So text transfer mem, we just map the buffer exactly as we do with vertices. So SDL map GPU transfer buffer GPU, and then the text transfer buffer the same cycle argument that we don't use. That gives us a row pointer to the memory. We need to not to forget to unmap it, of course. Unmap GPU transfer buffer, GPU text transfer buffer. And we do exactly the same with mem copy. So we say mem copy text transfer memory. We pass the pointer to the pixels, and we pass the pixel byte size. So pixels byte size, and that has to be int because it's Odin API and not STB image API that works with ints and not i32s. So yeah, at this point the pixels are in the transfer buffer, and we just need to upload it to the GPU texture that we have created. For that, we are gonna use the SDL upload to GPU texture function. We pass the copy path to it, where this needs to be done. And exactly like with the buffers, we pass the source, destination, and the cycle setting. Yes, so for the source, we specify, of course, the transfer buffer from which we wanna transfer. That would be our text transfer buffer. Then the offset, which is 0, because we are copying from the beginning of that special transfer buffer that we created for the texture. And these two have to do with how the pixels are laid out. But basically, if the pixels are tightly packed, like they are in our case, we can just not specify this at all, and it will assume that the pixels are tightly packed in the memory and just read it as this. So basically, we don't need to specify anything more here, only the transfer buffer. Now for the destination, we specify this GPU texture region here, and of course that needs to have a texture. Then the MIP level and the layer, because we have only one, we can leave it as 0, because that would be the first MIP level and the first layer. X and Y and Z we can also leave at 0, because we are copying to the beginning of the texture. We need to specify the width, height, and depth. So the width is our image size that we got before, and the height is also our image size, but Y. And the depth, because we are using the just a simple 2D image, the depth is 1. We have only one layer. Yes, this needs to be, of course, casted to U32, because this is what SDL expects, and that is all. Now we have a GPU texture with pixels assigned to it, and maybe we could also release the transfer buffer for the texture that we created. So yes, this still works, but of course it still doesn't show us the textured quote, but we can consider this done. Now we need to assign the texture coordinates to the vertices. So this would be yet another vertex attribute. So let's maybe add it here. Let's call it UV, because these are how texture coordinates are also called. And this is just a simple pair of coordinates. So the 0, 0 would point to the top left corner of the texture, and 1, 1 would point to the bottom right corner of the texture. So because we have a quote, we can actually express it here as is. We say UV. So for the top left, as I said, that would be 0, 0. For the top right, that would be 1, 0, because 1, x, they are normalized from 0 to 1. Then the bottom left would be 0, 1, and bottom right would be 1, 1. Alright, now we want to make use of this vertex attribute in the shader, right? So we need to open the vertex shader and specify another attribute here. That would be the next location. The type would be vector2, because it's the same here. And the name would be something like UV, for example. And of course, if we add an attribute here, we need to specify it in the pipeline description here. So the vertex attribute, we need to add a new one. Don't forget the comma, add the location 2. The format will be float2, and of course the offset, just like with the others, should be the offset to the field in our data layout. And yeah, so basically that's it. And the next thing that we need to do is create a sampler for the shader. This is done using the SDL3 GPU sampler method. So we just pass the GPU and the create information. That will give us a sampler. So the sampler create info specifies the configuration for the sampling. For example, the addressing mode, in case we specify a texture coordinate outside of 0 to 1 range, like what should we do in this case? It could be repeating the texture or just clamping to the edge. The minification and magnification filters, like how to basically mix the colors, how to sample the colors when the mesh is very close or very far from the view, and some other stuff. So you can play around with that, you can read about this, but it's actually just safe to not specify anything and it will use the default values. Yeah, that's basically it. The sampler is created. Now we just want to make the shader actually sample the colors from the texture. So this needs to be done in the fragment shader. And we need to pass the texture coordinates from the vertex shader to the fragment shader, right? So for that we need to specify another out attribute. That would be the next location, and it also should output the vector 2. And we will not do anything at all in the vertex shader with that. We will just pass it as is, and it will be interpolated between the vertices. So we just specify out UV equals UV like that. Now we want to, of course, receive those UVs in our fragment shader. So that would be an input attribute with just name of UV. And we want to access the sampler here. And for that, we are using the uniform binding, similarly to the uniform buffer access in the vertex shader. So we say uniform sampler 2D, and then the name something like text sampler. And how we use it is with the texture function in GLSL. So texture, we pass the sampler and the UV coordinates. And maybe we can also multiply it by the color that we were passing, so we can tint it. Now another consideration is again this SDL resource sets that we need to specify explicitly. And as you can see here, for the fragment shader, if we want to pass a sample texture, we need to use the resource set of 2. So basically we do the same stuff as here. We specify the layout, but the set must be 2, and the binding is 0 because this is the only thing that we bind. Alright, now the last thing that we actually need to do is bind our texture in our sampler to the draw call. And how we do this is simply with SDL bind GPU sampler for the fragment shader, so fragment samplers, and we specify which render pass, of course. And then similarly to the vertex uniform data, we specify from which slot we want to start, then the number of bindings. And since we have just one binding, we can also inline the structure right here. So we would specify it like this: SDL GPU texture binding, texture sampler binding. And this is a very simple structure. It just needs a texture and a sampler. So we say texture equals texture and sampler equals sampler. And hopefully now it will work. But it doesn't. Yeah, it doesn't work actually, because also what you need to do is specify the number of samplers when you are loading the shader. So this is something that I forgot. We need to do this. We need to specify it as an argument to the load shader function, like this, and pass it to the create GPU shader call. So maybe we could use name arguments here to avoid some confusion. So that would be num samplers, and we want 0 samplers for vertex shader and 1 sampler for the fragment shader. And maybe to avoid some confusion, we would also name this argument here for the number of uniform buffers. Now that seems to be working. So maybe let's move it a bit closer to the camera. And you can see, nice, it's very good. Maybe we can remove the tinting. For that we could just specify a color of white. So we multiply every channel by 1. So let's say white SDL F color, and just every channel will be just 1, 1, 1. and 1. And instead of the colors that we specified here last time, we can just pass white. And voila, here we have the beautifully textured quote. So yeah, that's nice. I guess next time we can do some camera stuff, maybe move around with SDL. So yes, stay tuned.